bearing capacity over factor of safety, that is net, it's not not. Hello?
Oh, sir.
Hello? Yeah, that place should be net, not, please. It should be net ultimate bearing capacity over in factor of safety. So then we have it to be, we have the Q net equals to net ultimate bearing capacity, which is equals to Y lambda F, Y lambda TF. So Q or net will give us Q bearing capacity minus the Q over Fs. Then we can solve any equation. We come to a problem also here. The other day we solved a lot of questions. Now there is another question here also that we're going to solve today. Then I think I have to move to this side. So we have in a set, some work examples over there where we have a square foundation is 2 meter by 2 meter in plan. This is the design. The square foundation is 2 meter by 2 meter in plan. The soil supporting the foundation has a friction angle of phi equals to phi prime equals to 25 degrees, and C prime equals to 20 kilonewton per meter square. The unit of soil, which is lambda, is 165 kilonewton per meter cube. Then determine the allowable gross load on the foundation with a factor of safety of 3. Then assume that the depth of the foundation is 1.5 meter and the general shear failure occurs in the soil. Now we should determine the allowable gross load on the foundation. So the allowable gross load on the foundation, we use the first equation of where the desired the correction that they made on the circular, square, and rectangular footings. They use the first circular footing equation. So they improve on this equation, and this is what we have. We have this equation there from the table. You go back to the table that we have. Phi is equals to phi 25. When it comes to this table that we have here, our phi 25. Phi 25. When it comes to phi 25, you will have our NC. Hello? Hello? Are you following me? Are you following me?
Yes, I want to ask a question.
Yeah.
That means always if they give you the power, you need to check it from the
see the power here. The question in the angle given, it was 25 degrees.
Yes.
So it comes to this table, you have the phi 25, then you pick NC. NC is what? 25.1. Yeah?
Yes, sir.
Then you come to NQ. When you see the 25, then you go to the horizontal. You go to the column of NC. 25, we have 25.1.
Yes.
Then we come to NQ. We have 12.7. We have NQ. We have 7. NC prime, we have 19 point, we have 14.8.
8.
Yes, you read all these values.
Okay.
Then begin to come to the equation. You come to your solution, your equation. You have them there. So then you begin to put in your values. The equation is given over there. But your lambda in the question was given as what? Is 165 kilonewton per meter cube, right?
Yeah. Yes, sir.
So then you put in your, it should be 16.5, okay? I think there was a mistake there, 16.5, not 165, 16.5 kilonewton per meter cube.
Okay.
So then you slot in the equation. So you get your gross bearing capacity. Okay, you have your allowable gross load on the foundation. You have your allowable gross load on the foundation. Now, that's the allowable gross load on the foundation. You got it?
Yes, sir.
Hello?
Hello, sir.
You got it. So you have your allowable gross load on the foundation to be 1078.29 kilonewton per meter cube. That is the allowable gross load on the foundation, right?
Yes, sir.
Yes. So if I don't have a marker here. Marker. Please give me some minutes. I'm going to take the marker and pen.
Okay, sir.
You let's go. I want to take some marker. When I illustrate on the board, can you see something?
So you write it
Okay,
down.
let's go. Let's go on.
Okay.
Let's go on. But you can see everything from here. The note is self-explanatory. I've done everything there. So then when it comes to the second question, we say a square footing is to be considered, is to be constructed on a deep deposit of sand at a depth of 0.9 meter to carry a design load of 300 kilonewton with a factor of safety of 2.5. The groundwater table may rise to the ground level during rainy season. Design the correct dimension of footing given sites. Given us Y sat, that is Y saturated. That is a lambda saturated, right? Lambda saturated during rainy season. So they said design the planned dimension of footing given lambda sat. Now we are saying that we are giving all these equations over there, where the lambda sat is equal to 20.8 kilonewton per meter cube. While the NC is given as 25, NQ is 34, lambda is what? Is 32. So we are only trying to find the angle where RW1 is this one. RW1. So the RW1 and the so now when you have a very capacity equation here, from here, yes. Please let me take a marker and come,
Yes, sir.
Very capacity over front of safety, that is net, it's not. Hello?
Oh, sir.
Hello? Yeah, that measuring length